Hey everyone, welcome back to Roboarmy. Now download the code from the description box below and open it in the Arduino IDE. Let's understand how this code works. First, we include the Servo Library. The library helps Arduino generate the control signal required to operate servo motors. Next, we create 5 servo objects. These objects allow Arduino to control all 5 servo motors independently. After that, we create position variable for each servo. All servos start at 90 degree, which is the center position. Now comes the setup function. This function runs only once Arduino powers on. First, we attached all servo motors to their respective pins. This tells Arduino which pins are connected to which servo motors. Next, we move all servos to their initial center position. As soon as the Arduino starts, every servo moves to 90 degree. This 90 degree position is important for Robotic Arm assembly because it helps us set the servo horns in the correct center position. Now we configure all push button pins. Input underscore pull up mode activates Arduino internal pull up resistors. This means we don't need any external resistors for the button. When a button is pressed, the corresponding pin leads low. Now comes the main loop function. This function runs continuously. Let's understand servo 1 first. When the clockwise button is pressed, the servo position decreases by 1 degree. The constrain function ensures the servo stays within a safe range between 0 to 180 degrees. Then the new position is sent to the servo motor. For anti-clockwise movement, when the servo second button is pressed, the servo position increases by 1 degree. This creates smooth movement in the opposite direction. In the robotic arm, this means the base servo can rotate the arm clockwise and the anti-clockwise. The exact same logic is repeated for servo 2, 3, 4 and 5. Each servo has its own position variable and its own pair of control buttons. This allows all 5 servos to be controlled independently. According to a robotic arm architecture, servo 1 controls the base rotation, servo 2 controls the shoulder movement, servo 3 controls the elbow movement, servo 4 controls the wrist movement, servo 5 controls the claw or gripper movement. So when we press any button, only the related servo motor moves according to its role in the robotic arm. Finally, we add a small delay. This delay slows down the movement slightly, making the servo motion smooth and easy to control instead of jumping too fast. Now connect the Nano to your computer using a USB cable. Open Arduino IDE, select board Arduino Nano. Processor 80 328P, choose the correct COM port. Now click upload. After a successful upload, all servo motors will move to 90 degrees. Now you can properly attach and tighten the servo horns on the 3D printed robotic arm structure. After that, disconnect the USB cable if desired and power the system using the external power supply. Press the button connected to servo 1. The base servo should rotate smoothly in the both direction. Now test servo 2. The shoulder part of the arm should move up and down. Now test servo 3. The elbow part should bend forward and backward. Now test servo 4. The wrist part should change its angle. Now test servo 5. The claw or gripper should open and close. Each servo can be controlled independently using its dedicated button pair. And that's all. Your 5 servo motor controller using Arduino Nano Expansion Board is now ready. You can use this project as a servo testing system or as a simple 3D printed robotic arm controller. We hope you found this tutorial helpful. Thanks for watching and keep building with Roboarmy.
Roboarmy. One-stop global community for teens in robotics and AI.